Okay, let's work on this one. It's a little differentiation from our IGCSE question. To find dy by dx, remember the rule is times by the power, take 1 off the power. So times by the power 3, take 1 off the power x squared. Times by the power 2, take 1 off the power, gives you 1. We don't need to write that. Now, I like to think of these as something separate. Now, if you think of this as something separate, it's exactly the same as mx plus c when you've got y equals mx plus c graph, and the gradient of that is just the m bit, so just the minus 8. So that will just differentiate to give you minus 8. So remember, x's just go to the number, and numbers just cross them out. They have no effect to the gradient. They shift the whole graph up. Remember, dy by dx is the gradient function. It's very important you remember that this is the gradient function. Okay, so we've got 3x squared minus 2x minus 8. Remember the rule? Times by the power, take 1 off the power. Now for turning points, okay, these are turning points where it flattens. Now if it flattens, the gradient dy by dx equals 0. So if that equals 0, 3x squared minus 2x minus 8 equals 0. So let's factorise this. Okay, and what can we see? We can see you get 3x plus 4 minus 2, sorry. So you got minus 2 times the 3x gives me minus 6x, 4 times x gives me the 4x, so that gives me the minus 2 in the middle. We know we get the 3x squared, 4 times minus 2 gives me minus 8. So therefore x, well let's just write it out properly, that's 4x equals 0, or x minus 2 equals 0. Let's scroll down a bit. So x will equal minus 4 over 3 for that one, and x will equal 2 over that one. And we've worked out our two x coordinates for our turning points. Now it says, show the x-axis is a tangent to the curve C. So what does that mean? So if x-axis is a tangent to the curve C, that means the x-axis is horizontal, so the gradient is 0. So one of these two, so you're either going to have this situation where the first one is going to be equal to 0, or you're going to have this situation where the second one, sorry, I was meant to touch it, fifth time lucky. So where this touches the x-axis, the tangent's here. Let's draw the tangent. So the x-axis forms a tangent here or here. So at one of these 2 points. So if the x-axis forms a tangent at one of those 2 points, that means at one of these 2 points, the y value must equal 0. So at either x equals minus 4/3 or x equals 2, y will equal 0. So you put these two things back into your original equation. So our original equation is x cubed minus x squared. So we put those back into our original equation. So let's go and get a calculator. We're going to do, well, let's just do 2. So I need to write down the equation is what I need to do. Y equals x cubed minus x squared minus 8x. Y equals x cubed minus x squared minus 8x, I think it was plus 12, wasn't it? Yep. So I need to put these numbers in. So x equals 2. Let's do the 2 one first. That makes it nicer, and hopefully that'll be the right answer. So we get y equals 2 cubed minus 2 squared minus 8 times 2 plus 12. So that equals 8 minus 4 minus 16 plus 12. 8 plus 12 is 20. Minus 4 minus 16 is minus 20. So therefore y equals 0. Therefore tangent at what's the point? 2, 0. Okay, so therefore the x-axis is a tangent at the point 2, 0. I don't need to show that the other one is. All I wanted to do was show the x-axis is a tangent to the curve C. I put the 2 in because it's nice, some numbers to work out. Minus 4/3 is not likely to be a tangent at this point. It's going to be quite hard to get another turning point exactly the same point. Okay, on a cubics you either got this, or this shape going on, and you can see it's not possible to have 2 of these going to be parallel to the x-axis at the same time. Anyway, but it only asks us to show that it happens to be so, and we found it. Okay. Right. Next question.